Welcome to lesson RT2, lesson 5. By the end of this lesson, you'll be able to find the area of shaded regions using special right triangles and circle properties. All right, let's look at our first example here. It says to find the shaded area. So I'm just looking to find that shaded pink region. All right, so let's first consider that we are working with a circle. An area of a circle is pi r squared. Now, as I look at this, though, I'm only really dealing with half of the circle. So I'm going to do half pi r squared. So this is half of our area of our circle. And then what I'm going to want to do is I'm going to want to take away the area of our triangle. Remember, the formula is 1/2 base times height of that triangle. As you may recall, we know that this is a right triangle because it is inscribed in a semicircle. This is important for us to know because now I can see that I have a 30-degree angle and a 60 and a 90, and we know about a 30, 60, 90 triangle. Let's just recall the relationship that we learned. Across from our 30, we call x. Across from our 60 is x squared of 3. And across from the right angle is our hypotenuse, which is 2x. 14 squared of 3 is across from my 60 degree. So I know that that's x, the same as x squared of 3, which tells me that our x value is 14. And our hypotenuse is 2 times 14, or 28. This gives us a lot of information. We can find our area of our triangle now and the area of our circle. If we're looking at the area of our circle, we have 1/2 pi. My radius is half of my diameter. If the diameter is 28, the radius is 14 times 14 squared minus 1/2. The base of our triangle here is 14. The height of our triangle here is 14 square roots of 3. All right, now let's do some simplifying. So 14 squared is 196, divided by 2 is 98. So we have 98 pi. From here, then, we're going to simplify. We'll do 14 times 14 again, and we'll divide it by 2. So we get 98 over here. Then we can't forget our square root of 3. One of these has pi, one has square root of 3, so we cannot combine them because they are not like terms. So this is our final answer. Here's another example where I see a circle and a circle and a triangle. We need to find the area of the shaded region, which is everything except for that triangle. So let's first start with the area of our circle, because that's the whole. So we have pi r squared, because this time we want the whole circle. Then we're going to take away the area of the triangle, 1/2 base times height. Across from the 60 is our x squared of 3. Across from the 30 is x, and the hypotenuse is 2x. So here I want to find my x, and I see there that it's the same thing as 20, which means that 2x is 40. The diameter of our circle is 40, so that means the radius is 20. We now have enough information to substitute into our formula. So I have pi times the radius, which is 20 squared, minus 1/2. The base of the triangle is right here, so 20. The height of the triangle is right there. Remember, the base and the height must be perpendicular. Now we can go ahead and simplify. So we need to do 20 squared, which is 400. So I have 400 pi minus 20 times 20 is 400, divided by 2 is 200 square roots of 3. 400 has pi, 200 has square root of 3 with it, so they are not like terms. I cannot combine these together, so I'm going to leave this as my final answer. Again, in our next problem, we need to find the area of the shaded region. In this case, though, we are working with a kite. I know that these two angles will be 90 degrees because they are a radius connected to a tangent. To find the area of our shaded, we're going to have the kite, right? And we're going to take away this portion of our circle, that sector, which we're going to use that angle measure, and we can see that it's 120 out of 360 degrees. That's the section that we have, and then it's pi r squared. We've learned that the area of the kite is our diagonals here cut in half. Diagonal and diagonal cut in half. But actually, we are going to look at this one a little bit differently because we have right triangles here. Okay, and we know it's a 30, 60, 90 because if I've cut this in half, 120 divided by 2 is 60, which makes this angle our 30. For our area of our triangles, we have two of them, so we're going to do 2 times 1/2 base times height of the triangle. We need to find the base. I have the height. Remember, those need to be perpendicular. Using our special right triangle, across from the 30 is x, across from the 60 is x square roots of 3, which tells me that our x is 14. So I'm going to substitute what I know, 2 times 1/2. The base of our triangle is 14. The height of our triangle is 14 square roots of 3. I'm going to bring the other part of our equation down. So we're going to take away 1/3, because that's 120 over 360, simplified, pi, times my radius, which is the same thing as this length right here, which we found was 14. So times 14 squared. Now we just need to do some simplifying. On the left, 2 times 1/2 reduces to 1. 14 times 14 is 196 square roots of 3 minus 14 squared, which is 196, divided by 3 is 65 1/3 pi, or I could leave that as 196 over 3 pi. Either way is fine. We cannot combine these two terms because they are not like terms. Again, we're going to find the area of the shaded region, and here we have our kite. And then we're going to take away 1/3, since it's 120 degrees out of 360, pi r squared, because that's the sector of our circle that we're working with. For our kite, to find the area, we're going to use that same idea that we have two right triangles that we're working with, and it is still a 30, 60, 90. Again, our relationships going across from the 30 is x, across from the 60 is x squared root of 3. So in this case, we know our x, which is 9. So the long leg is 9 square roots of 3. From here, we can substitute in. We know for our triangle, we're going to have 2 1/2 base times height, because that's going to help us find our kite, both of the triangles. Then we take away 1/3 pi r squared. So for our kite, our base is 9. Our height is 9 square roots of 3. Take away 1/3 pi. Our radius is right here. So we have times 9 squared. Now we need to just go ahead and simplify. 2 times 1/2 is just 1, so 9 times 9 is 81 square roots of 3 minus 81, that's 9 times 9, over 3 pi. We can simplify 81 over 3, which is 27 pi. Bring everything else down. 1 has square root of 3, 1 has pi, so I cannot combine these because they are not like terms. So that is our final answer. In example number 5, we're going to again find the area of the shaded region. Here I can see that I have a 45, 45, 90, and that is because this leg is congruent to this leg because they're both radii. which means that this is a 45, 45, 90, because those are congruent. So I have an isosceles right triangle. Here, as we work on this, we can see that we have just a portion of our circle, which would be a sector here, which is 90 out of 360 pi r squared. And we're going to take away the triangle, which is 1/2 base times height. And that'll leave us then with our green shaded section at the bottom. 90 over 360 pi, my radius is 12 squared, it's a 2 squared, minus 1/2. The base is 12 square root of 2. The height is 12 square roots of 2. Now we just need to simplify. 90 over 360 is the same as 1/4. 12 square roots of 2 squared. Remember, we learned that that's 12 square roots of 2 times 12 square roots of 2, which is 144 square roots of 4, which is equal to 144 times 2 times pi. And then we have 1/2 again times 144 times 2. 144 divided by 4 is 36 times 2. We get 72 pi minus 144. These are not like terms because one has pi and one does not, so we're going to leave that as our final answer.